And welcome, stargazers, to the Daily Space Weather. Another fascinating episode coming today. We've got coronal mass ejections, some very complex sunspots, and a very high likelihood of major solar flares. We'll talk about it and lots more. Also, solar cycle information and tons of fascinating stuff today. Some even debunking of nonsense about to come your way. So, and of course, there is plenty of that on YouTube. So, let's get to it. This is the past 24 hours from SDO in 171 angstroms. It's one of the many species of ionized iron covered by the SDO, and it shows the lower corona. You see all these magnetic loopy-looking features. They might look like magnetic field force lines because, well, those are indeed the forces that are suspending those large expanses of plasma. So there's the northern hemisphere, and we've got two major sunspot groups. So this one right here and this one over here are both capable of producing X-class solar flares. So flare watch in effect. We've also got CMEs happening. Some of them may have earthly directed components. We'll get to it later in the video. So lots of stuff to cover today. We'll try to sort of keep the pace moving here. Here's the equatorial view. In the house favorite wavelength from the Solar Dynamics Observatory. There is the southern polar region. We've got coronal holes to talk about as well. Also solar cycle progression. What's going on with it? Again, we'll get to it. First, let's take a brief look at what's going on with sunspots. So here's a quick yesterday plus today series of images from SDO. And this sunspot has grown massively in the past 24 hours. Again, two major groups there in the northern hemisphere raise the likelihood of X-class solar flares a lot. This is by far the most likely place to see an X-class flare at the moment. And for the coming 48 hours, that will continue, assuming those sunspots don't suddenly degrade. Here is the colorized magnetogram for the same period of time. That's yesterday, June 26th, plus today, June 27th so far. It's to about, 11 o'clock universal time. And check out the rapid growth of that sunspot. It's got significant magnetic shear, and that is the feature that makes sunspots likely to produce large flares. This one's got magnetic shear and it's approaching the limb, so it's very likely to produce a large solar flare. By the way, take a moment to visit our sponsors and affiliates if you haven't. Please support the channel that way, as we have been trying for a few years here to make our YouTube channel into a sustainable operation. So help us do that and maybe help your own health out by picking up some products from hemplucid.com. You can find a link below this very video in the description. You can find a link on our homepage as well. So do your shopping via our links. Again, you can find a link in the description to the Hemp Lucid shop. Also on the homepage at smashomash.com. Great products there, whether it's CBD tinctures, mushroom gummies, immune stacks, CBD body balms and lip balms, even CBDs for your pets. Another affiliate link you may find there is the Amazon link. It's amazon.com/shop/smashomash. Today's featured product is Alexander Unziker's The Liquid Sun, A Coming Revolution in Astrophysics. Yeah, it's pretty serious. And I'm not going to explain what it's about. However, I'll just say this. If stars are made of condensed matter and not gaseous plasmas, guess what? They're actually much more stable than nearly anybody in the world believes. So, I guess if it bleeds, it leads. That's not really good for us, but it might be good for civilization. Anyway, stars, are they made of condensed matter or gaseous plasma? Let us know in the comments what you think. By the way, if you enjoy lifestyle and fitness posts and things like that, make sure you join us over on Instagram. You'll find some additional content there about things like diet, exercise, etc., training tips, and so forth. So let's take a look at volcanic activity here for the past 24 hours. Shivaluch now back on the list as it explodes. It's producing a 12,000-foot plume of volcanic ash. Please don't pole vault the caldera. Again, please do visit the links below the video in the description as well as on our homepage at smashomash.com. Abiko also erupting, 10,000-foot ash plume there, flight level 100. Kuchinorabu-jima in the Ryukyu Islands of Japan has reported that seismic activity has been increasing since the 17th of June and is still continuing at the time of the update. The warning bulletin states that ballistic impacts of volcanic bombs could affect an area of about 1 kilometer. Please stay more than 1 kilometer away from Kuchinorabu-jima. Try saying that 3 times in a row fast. Subanose-jima also erupting there in the Ryukyu Islands, flight level 080, 8,000-foot ash plume. Unknown ash plume from Mount Mayan on the Isle of Luzon, Philippines. Probably still erupting. It's been pretty spectacular in the past week or two. Ibu, discrete emission, produced a 7,000-foot ash plume. Popocatépetl exploding, flight level 220. 22,000-foot ash plume there over central Mexico, thanks to Popocatépetl. Flight level 220. Flight level 150 over Fuego as it explodes in Guatemala. Sabancaya, weak emissions and possible volcanic ash emissions. And Ubinas exploding in Peru, flight level 200. It's a 20,000-foot ash plume. And let's check seismicity. So here's what's been shaken over the past 90 days. And let's check the last 24 hours. It's been very quiet as far as earthquakes. It looks like only a couple in the 5 magnitude range, which will be the ones we'll cover. 5.2 at Tonga, struck at about 12:36 Universal Time yesterday afternoon. As that remains the most seismically active region in the world there. A little quake swarm in the Caribbean. Shout out to Peter Schiff. If you don't watch Peter Schiff's podcast, maybe you oughta. Peter Schiff, a real economist who does not answer to anybody except his own investors. Only 1 5 magnitude quake in the past 24 hours. It's been very seismically calm. And let's get back to space. I'm excited about it. And we're excited to have stargazers like you tuning into the channel. Here's the past 24 hours in ionized helium from SDO. That's 304 angstroms. Another portion of the extreme ultraviolet electromagnetic spectrum. And thanks for leaving comments, general_disturbance. So you may see a bunch of plasma motions there, both in the northeast and around the western limb. Really the entire eastern limb, the northern polar region. Lots of stuff moving around. Here's a great inset that we've created. There you go. There's some sweet plasma. It's dag. Well, I guess that's a quick way to get a suntan. Cheers. Hey there, El Sol, Helios. You know, it's always sunny in Philadelphia, and it's always sunny in space. We've also got the southern hemisphere. And let's take a look at some more stats here. And we're going to talk solar cycles. Yeah, solar cycles. But first, the 10.7 centimeter radio flux. It's come up a little bit here to 158 solar flux units. And that's mainly a result of the growing of that massive sunspot right in the north-central region of the solar disk. It's right in the, to quote Tamitha Skov, the Earth Strike Zone. My voice sounds better at saying Earth Strike Zone than Tamitha's does, but hey, what can you do? So there's the 1 year graph, the 10.7 centimeter radio flux there depicted in the black line. The red line is a sunspot number, which, as you can see, once again reached 200. Notice some accurate forecasting coming from the channel yet? Oh, well, congratulations on realizing it exists. So here's NOAA's forecast, and it looks like NOAA actually is forecasting a glancing blow there to arrive on July 1st. So a minor CME there. It's mainly off to the east. So that's NOAA's forecast. Based on what it's showing there, it's not going to cause very much of anything. Maybe a KP3 or 4 at the most. Again, that's based on NOAA's forecast. We haven't done our analysis yet. That happens later in the video. So we'll just let that play through one more time there. The NOAA Enlil spiral from the Space Weather Prediction Center. And while we're on this page, There's the NASA forecast. NASA has the CME farther to the east. So NASA's expecting it to even miss Venus. But yeah, so there's the NASA forecast. And let me get out of the way there. Anyway, let's briefly head back to the Space Weather Enthusiast dashboard here to see what NOAA's forecast is for space weather for the coming days. We like to look at all of the data and then make our own decisions. So they're actually forecasting some geomagnetic unrest later today. Well, I'm sorry, earlier today. Yeah, around 6 to 9 Universal Time, they forecasted geomagnetic unrest. I have no idea why. 3.67 kp index. I'm not so sure that happened. But anyway, that's the forecast. We'll get to our forecasts for coronal mass ejection impacts soon. And let's talk about solar cycles. So a paper just came out from Live Science. Solar maximum could hit us harder and sooner than we thought. How dangerous will the sun's chaotic peak be? Well, a lot of people on the internet are telling you that an inactive sun is very dangerous. A lot of people on the internet will pivot, I guess, to tell you that an active sun is dangerous. And did you know that shorter solar cycles, generally speaking, have a tendency to be very strong solar cycles, and very long solar cycles have a tendency to be grand solar minima? Yeah. That's sort of the basis for the sunspot number is inversely proportional to the length of the cycle. I'll just say that. Lots of sunspots equals a shorter cycle. Few sunspots means a longer cycle. And I love that right there. It says what causes a solar cycle. The answer is nobody knows. So mainstream astronomers believe that it's an internal nuclear fusion dynamo that drives the solar sunspot cycles somehow, but it's really not understood how the field stays so consistent and why it would do such things. Other people believe the sun is very different than that, which is why I referred the book that I referred earlier in this video. So, of course, we know that magnetic fields drive the solar sunspot cycles, and they reverse every 11 years and so forth. Again, there's a great article on livescience.com here. It even has quotes from Scott McIntosh, somebody who's been actually accurately forecasting solar activity for the past about 3 or 4 years. So maybe have a read on that. And, I mean, here's what the forecast used to be. So back in, let's see, when did this get... So this is back in 2019. Solar experts predict the sun's activity in solar cycle 25 to be below average, similar to solar cycle 24. How's that worked out? That has been what we call a failed forecast. They're expecting the sunspot range to be between 95 and 130. Notice how we just got to 200 recently. So there's an article about 2019. That's been utterly debunked by just looking at the facts of the solar cycle. Now, we do market research on the channel. And I can quote this particular content creator as saying to me directly, "Oh, our viewers are stupid." Which, whatever. I mean, hey, maybe your viewers are stupid. But there's a big difference between ignorance and stupidity. Ignorance is the key to all. Ignorance is the root of all knowledge. You have to not know a thing before you know a thing. So let me just play a brief moment here. I won't subject you to too much of this nonsensical video.
Necessarily mean we're going to see a large solar storm now. All the large solar storms in history happened during solar minimums.
So here is Talc, David Moriello, aka Talc. And what he's trying to say is that, so here's solar cycle 24. He's trying to say that what we see is Valentina Zarkova's forecast. You see that? Does that look like the current cycle? We've already exceeded the output of solar cycle 24, which means all of this nonsense on magnetic reversal news is debunked in less than 20 seconds. So that's pretty pathetic. And let's talk about solar cycle lengths. So anybody who knows anything about this would know that a new method has been recently determined. Well, I won't say recently. This is practically as old as my cycling career. A new method to determine the solar cycle length. How new? 1998. This was published in the Geophysical Research Letters, Volume 25, on June 1st, 1998. And what's the point I'm making? You can read the paper yourself if you just search for it. The point is that right there. You see that? Well, it might not make sense to you, but the point is, Notice solar cycles can be as short as less than 10 years. The strongest solar cycle that we've had in recent history was solar cycle 19. And of course, the one peaking around 1991, that one was only 9.7 years. So generally speaking, short cycles are strong cycles and long cycles are weak cycles. It's just a basic fact. And we invite everybody that watches Magnetic Reversal News to do the math. Also, talc. Feel free to do the math. Stop sucking at it. Here's the equation. 8 equals capital D. Save 20% on your Redbubble products. So we've decided to do the math with a very high resolution image of the closest star there during a period of some activity. It was from back in February. And a great image there from SDO along with our math equation, which we share with people regularly on social media, especially ones who have their head so far up their ass that they're viewing the world through their esophagus like a snorkel. It's pretty pathetic. And, I mean, wow. Could you be any more in denial of reality? Hey, Diamond, snap out of it. Leave the grand solar minimum cult and enter into reality. You're invited. In the meantime, do the math. Don't suck at it. And, I don't know, save 20% on all Redbubble shop orders. Let's get back to space facts. Here's the past 4 hours of Earth's magnetic moment from space. And by the way, if Earth's magnetic fields were flipping, this would get all funky. It's not getting all funky. It looks totally normal. That's magnetohydrodynamic pressure, Earth's magnetic moment from space, for the past 4 hours. You can see most of the pressure there on the magnetotail side as the system tries to reach static equilibrium. Here's Earth's magnetic moment from the ground, and this depicts magnetic flux density. That's it, nanotesla. Earth's magnetic moment from the ground. Again, things are geomagnetically calm on planet Earth right now. There is a high likelihood for major solar flares, radio blackouts, etc. So anyway, planetary K-index currently only at 2.33. We never really reached NOAA's forecast, which should have been right here at 3.67. It only got to 2.67. 2.33 is the current planetary K-index, an average of global geomagnetism. Next, the real-time solar wind here, pretty unremarkable for the past 24 hours. Very low density here at only 1 proton per cubic centimeter. Keep in mind that is only the ACE spacecraft. So the plasma environment can be vastly different between two different spacecraft orbiting the Lagrangian 1 gravitational point. It's about 1 million miles from Earth, and again, the plasma environment can be vastly different for the two spacecraft. So as far as the ACES measurements go, that is a very diffuse solar wind at only 1 proton per cubic centimeter. Solar wind speed here, 512 kilometers a second. That's like 1 million miles an hour or something like that. And here are our GOES magnetometers. Fairly smooth there. Fairly unremarkable. Let's move on to something that's a lot more remarkable, the heliospheric current sheet. So this is super important. This green blob here, I've been talking about it for, well, most of the solar cycle. Maybe not every day, but we are waiting for that to suddenly migrate, and it's swinging right into the Earth-facing zone. So we're hoping that coronal hole moves while it's facing Earth, just so we can document it and see if anything happens with the chromosphere and so on. But in any case, you can see some activity happening over here in the east. So if you bring up the last image here, you'll see this sector boundary crossing forming. That has to do with likely large sunspot in the northern hemisphere. So don't be surprised to see a large sunspot rise in the northern hemisphere in the coming day or two. That's the top view ecliptic plane field plot depicting the solar plasma in its magnetic polarity. Green for north, red for south. Here's our line of sight field plot. Here the solar B field depicted in blue. Solar polar fields in green for north and red for south. And of course the grayscale portion, that would be the gong magnetogram. That data is derived from 51 ground-based magnetometers and magnetometers on stereo A and stereo B, which brings us to coronal holes. So here's our coronal hole line of sight plot. And once again, after that plays through one more time, let's bring up the last image here, because this very important coronal hole up here at the northern polar region is what we are waiting for. This coronal hole, let me get rid of that. This coronal hole right here needs to move down to the equator and frankly all the way to the south polar region. So that is the thing that we will see happening. That is just a fact. That's barely even that's not even really a forecast. That's just a fact of how heliophysics works. The coronal magnetic fields, they behave this way during every solar sunspot cycle. So let's take a look at coronal holes here. We're going to switch from 304 angstroms to 211 angstroms. And so here's this North Pole coronal hole, and this thing can suddenly lurch to the south. Basically what would have to happen is a bunch of plasma would have to get out of there. Whether it reorients or goes blasting into space doesn't really matter. Coronal holes can suddenly move. And if this one does, you can expect to see a further uptick in solar activity in general. Here's the most well-defined coronal hole right now. It is just moving into the Earth strike zone. Shout out to Tamitha Skov, a real space scientist. And by the way, Tamitha Skov knows a lot more about space weather and astrophysics than I do. She has multiple PhDs in related fields. So there's the southern hemisphere, the most well-defined coronal hole. Here's the full disk view. In that wavelength, the best wavelength to view coronal holes, at least from the SDO AIA instrument. It is depicting ionized iron, which this species doesn't like to be around coronal holes. It highlights them quite well. So let's talk about sunspots. I guess those are kind of important, right? We've got two major, let me reiterate. This sunspot group over here is really likely to produce an X-class flare. This sunspot here is also quite likely to produce an X-class flare. And if you're afraid of the sun, just remember, it is the provider of all light and life and heat on the planet, basically. So there's that. Maybe not all of it, because of course some heat is generated if something like a meteorite strikes the Earth. However, meteorites are affected by the sun's gravity anyway, so let's don't get into that anymore. We've still got quite a few sunspots here. I mean, the sunspot number has dropped a lot, but we do have a very high likelihood of major solar flares. Continuing on to the energetic particles portion of the video, the GOES proton flux, no spikes in it here. It's been quiet as far as solar energetic particle events for a long time. GOES X-ray flux here, featuring only one M-class flare in the past 24 hours. The background X-ray level is probably someplace around a C1. But there's a little bit of volatility happening, and you can expect that to continue with those magnetically complex sunspot groups. Next, let's see what's going on overhead. This is my star chart for Lehigh Valley, Pennsylvania from skyandtelescope.org. Put in your zip code or your town to make your own if you like. Mercury getting very close to the sun there. And if you move this ahead to the dusk sky, you can see Mars and Venus getting very close together there on the ecliptic. They are actually very far apart, very far apart. Remember, folks, things are not always as they seem. Some things are quite counterintuitive in the realm of science. Here's your solar system forecast. People are going to be interested in where planets are and so forth. So let's show them. There's where things will be in 1 week. July 4th, full moon. It'll be a great day to be, I don't know, staying up all night or something. Maybe you are a werewolf. If so, let us know in the comments. Next, coronagraphs, and we've had some spectacular CMEs in the past 24 hours. Well, there you can see one of them blasting out of the east side, one blasting out of the north side. That's yesterday's coronagraphs. That's only 66 frames for whatever reason. Some missing data there, probably from